I can determine whether an equation has no solution, one solution, or infinitely many solutions. The topic is solutions to linear equations in one variable. The solution of an equation is the value of the variables that makes the equation a true statement. Another word for variables is letters. And you can have any letter for a variable except for I and O. We don't suggest that in math because O can be considered the number 0, and I is an imaginary number, and you'll use imaginary numbers when you get to higher levels of math, like Algebra 2, like maybe your junior year in high school. Now, values just means a number, okay? So we want to make sure that we understand the difference between the two. And equations in one variable can have one solution. It can also have infinite solutions. Infinite just means many solutions, or it can have no solution. And we're about to explore the different ways that you can have these different types of solution. So under one solution, it says the reasoning, what the type of solution means. So we want to understand what a one solution equation means versus an infinite solution equation versus a no solution equation. So one solution, you only have one value, that's one number, that would actually make the equation true. So that means it has only one number, that means one value that will make that equation true. For infinite solution, it's the same as saying many solutions, which means you can have any value that will make the equation true. So it can be any number. So any number in that solution can make that equation true. For no solution, that means you can have absolutely no value. That means no number at all that will make the equation true. So that means no number at all that you could substitute in that to make that equation true. So that's the reasoning, the understanding behind it all. So when we're looking at the differences, I want you to know this. The difference between one solution, infinite, and no solution. For a true solution, for one solution, it's sometimes true. Not all the time, but sometimes because it's conditional based upon some values of x, which means there's only one true value or one true number that can make that solution true. Only one time that it can make the equation true. Okay? And we're looking at infinite solutions. The true solution is always true because it's the identity. The left side of the equation will always equal the right side. That means it is true for every single value, every single time. It is true. No solution, meaning it is never a true solution. You'll never have 4 equals 6. That would never ever be true. Okay? It's a contradiction. That means it is never true for any value of x. So not every time will it be true. 100% of the time, you will not have a solution no matter how you work the problem. Okay? Now we're going to take some time and we're going to go over some examples so that you can add this to your understanding of the differences between how to recognize whether it's one solution, no solution, or infinitely many solutions. So the first thing I want you to understand is how we need to look at this problem. We would need to understand how to move the variable on one side of the equation, and you always want the variable to equal a number. So we're looking at the left side equation. It's negative, so we want to add 5x to both sides. Okay, that would allow us to cancel our variables. And if we add it up, 8x equals the 3x plus 5x. Bring down your plus 9, that equals 41. Now we want to bring our constants to the other side, so we're going to subtract 9 from both sides. And when we subtract 9 from both sides, our 8x should equal 32. Now we're going to divide both sides by the coefficient. The coefficient in this case is 8. So dividing both sides by 8, that will leave us with our solution, which is x equals 4. Now that we understand that x equals 4, 4 is the only number that will make that equation true, which means it only has one solution, because that is the only number that we can substitute that will make both sides of the equation equal one another. Okay? So let's look at our next example. We're referring to infinite solutions. Excuse me. We're referring to infinite solution. You want to identify the like terms. So 5x and 5x are equal to one another, and 15 and 15 are constants, and they also are the same number. If we manipulate this equation to get the variables on one side, we will have to subtract 5x from both sides. If we subtract 5x from both sides, what you think will happen to the equation? Okay, I want you to think about that as we solve this problem, okay? Because when we're looking at identifying infinite solutions or no solutions, excuse me, you will see some similarities, which in this case will be the variables on both sides will be the same. But there's a slight difference. In this case, the constants are the same. So when we subtract 5x on both sides, that's going to cancel and leave us with a true equation. It's going to leave us with 15 equals 15, which checks correct. Okay? So when you are looking at infinite equations or infinite solutions, you're looking at an equation that any number for x will make the equation true, because both sides of the equation will be equal. So as we're looking at the no solution, again, I want you to recognize the similarities between a no solution and infinite solution. The constants are different. 8 and 3 are different, but the coefficients for 4x are the same. Okay? So if I subtract 4x from both sides of the equation, that's going to cancel out both of those 4x's, and it's going to leave me with 8 equals 3. But we know that's not a true statement, because 8 does not equal 3. So if you draw a line through the equal sign, that represents not equal. So on the side, I want you to write the not equal sign and write the meaning of it. So that symbol means not equal. So you cannot solve it and end up with 8 equals 3, because we both know that's not a true statement. No number for x will make this equation true. No matter how you size it, 8 will never equal 3. Okay? So make sure you wrote that down. Pause the video if you need to. All right, let's look at the hints at the bottom. So look at both sides of the equation. So when you look at both sides of the equation, the result will have what? A variable and a solution, which is a variable and a number. Okay? So you'll have a variable equal to a number. That's how you know you have a one solution equation. If you have an infinite solution equation, both sides of the equation will look the same. Of course, the variables will cancel each other out, but both sides of the equation will look equal. That's how you know you have infinite solutions. If you have no solutions, the variable will cancel each other out, and both sides of the equation will look how? They do not look the same. Why? Because I know that they will not equal each other. The left side equation will not equal the right side. So please make sure you study that. All right? So right now I need you to flip the page. If your sheets are double-sided. And I need to make sure that you write the word study somewhere big on top of your paper, because I need you to study this section. This is something you truly need to know, how to determine the different types of solution. If it is one solution, the variable terms are different. What are the variable terms in this case? 3x and 7x. 3 and 7 are different numbers. They're on the opposite sides of the equal sign, so the variable terms are different. That's how you know you have a one solution equation. When we look at infinitely many solutions, the variable terms are the same, and both sides of the equation are considered the same or are equal. So you can look at equation in its simplest form and determine, hey, what is it? If there's no solution, the variables will be the same and both sides are different. What other sides are different? The constants will be different. The constants will be different, because 9 and -5 are different constants. So don't get that confused with one solution which talks about different variable terms. No solution is different constant terms. So please make sure you understand that. Make sure you study that. It is very important for your test. All right, let's look at the examples. One example. The first one, we're going to use a distributive property where we're going to multiply 4 times x plus 2 times 5 plus 5 times 2x plus 5 times 4. So we distribute, we're multiplying 2 times 4x plus 2 times 5 equals 5 times 2x plus 5 times 4. That's showing that we applied the distributive property. Once we simplify, we have 8x plus 10 equals 10x plus 20. So we want to look at this equation and determine, okay, what is our next step? Once we have simplified the equation, you can go back to the table and determine what type of equation you're going to have. Automatically, you should say, hey, I should have what? One solution. Because when I apply the distributive property and I simplified both sides of the equation, you identify your variable terms. 8x and 10x are different. They're your variable terms and they are different. Because they are different, I know I have one solution. Okay? You want to now combine like terms and you want to solve for x. So if the equation can be solved for x, you already know that, hey, I need to work this out and get x equal to be a number. Okay? So now I want to combine like terms by subtracting 8x from both sides When you subtract 8x, the 8x's will cancel. And I now want to move the constant to the other side, so I'm going to subtract 20 from both sides, and now my constants cancel. So now I'm combining the constants. A positive 10 and a negative 20 gives you a negative 10. 10x minus 8x is 2x. Now we divide both sides by the coefficient 2, and x equals a negative 5. Make sure you box in your answer. X equals negative 5. So the equation has one solution. And the solution means that negative 5 is the only value for x that will make the equation true. So there's no other number I could substitute in here to make that equation true. Only negative 5 will make this equation true. All right, pause it if you need to. But let's get ready to move to example 2. So if you haven't solved it already, I would like you to pause the video and try to solve it on your own. At least the factoring part to be able to simplify it. Then unpause the video and check your work, and then we can finish filling out your notes for example 2. So first thing you need to do if you just unpause the video is to simplify both sides of the equation. So to do that, we want to apply the distributive property. And we want to distribute the number on the outside of the parentheses and multiply by each term in the inside of the parentheses. So we have 2 times 5x, which gives me 10x, plus 2 times 4, which is 8. Bring down your minus 11, equals 4x plus, and you're going to distribute that 3. 3 times 2x is 6x, minus 3 times 1 is 3. So now we want to combine our terms. We want to combine our constants together, and we're going to combine our variable terms together. So 10x, bring that down. 8 minus 11 is a negative 3, equals 4x plus 6x is 10x, and bring down your minus 3. As you can see, both sides of the equation are the same, so the variable terms are the same. Therefore, both sides of the equation are the same, which is equal. Because they both are equal, we can already recognize this is infinitely many solutions. You can actually stop right there because you can recognize that both sides of the equation are the same. So the solution of this equation has infinitely many solutions. That means x could be any number that you like. The solution means that any value, that means any number, any value for x will make the equation true. So that table at the top that I showed you earlier is very, very important because of this. Again, we're on example 3. If you need to pause the video to work out the problem first, and then we go back and fill in the rest together. So you can pause, work it out, and then unpause. All right, if you're just coming back, first thing we want to do is simplify both sides of the equation. So we simplify both sides of the equation, which means we're going to apply the distributive property. So we're going to bring down that negative 4x, which is the same as a minus 4x, and we'll distribute that 3. 3 times 5x is 15x, plus 3 times 6 is 18, equal 7 times 2x is 14x, plus 7 times 1 is 7. And bring down your minus 3x. Now, on the next line, we want to combine our like terms and then combine our constants together. Okay? On the left side of the equation, you have a negative 4x plus 15x is a positive 11x plus 18. 14x minus 3x is 11x. And bring down your plus 7. So if we can see here our like terms and we combine them, those of you who are like, how do you get 11x? Because you have a positive 14x minus 3x, that gives you 11x. And then on the other side, you have a negative 4x and a 15x. When you have unlike signs, you have to subtract and take the sign of the larger absolute value. Okay? So if you notice that with our variable terms, once we simplify them, they both say 11x, which tells me that my variable terms are what? The variable terms must be the same. So because they're the same, what happens to the constants? The constants are not the same, which means it's not equal. Because 18 will never equal 7. And 7 would never equal 18. So we continue to solve this by subtracting 11x from both sides. Our 11x's with our variable parts will cancel, and you're left with 18 does not equal 7. Always make sure you draw that line through the equal sign and show that it does not equal. No matter how many numbers you replace with x, you will never get a true solution. So the equation has no solution. And what this means is the solution means that there is no value at all for x that will make this equation true. So again, please mark at the top of your paper that I want you to study this. Make sure you know it inside and out. And I appreciate your time. Next thing we're going to do, I'm going to post your homework, and you can check your homework answers. Remember, your iReady teacher assign is due on Wednesday. I would suggest you finish it tonight because your quiz is Wednesday. Take care.